Hello friends. So this is a part of our GenAI series. Before launching the GenAI series, I thought why not show you one simple demo how this GenAI series is going to be. In this series, we will not only learn GenAI, we will learn everything that a professional GenAI developer needs, from system design to the core concepts to how the real world things work, and also how to optimize the system and what are the security principles we can include in our GenAI projects. So friends, in this project, at first we are not going to use the LangChain. We will see the core concept, how to build a GenAI system with core Python only. Because if you don't know how to set up with the core Python and if you directly jump to LangChain, it will have no use. Because at the end, you will not know how a GenAI system is working or how to scale a GenAI system. So in this part, we are going to see how a ChatGPT like system, or if we wanted to build our own ChatGPT system, how to think like that and what are the parameters that we need to think. Or before going to this video, let me tell you one thing. Here may be few topics you will think you don't know, but don't worry. In this series, we will cover each and every topic in minute. We will give every minute example with core Python so that it will be crystal clear for you. But in this video, I will try to explain those concepts a little bit so that you can understand what are the things going behind the ChatGPT system. So let's start. In this course, we are going to see how the ChatGPT internals work, and we are going to see with core Python implementation. We will see the API integration, conversation memory, temperature control, error handling, CLI interface, token cost estimation, and many more things. It will be of two parts video. In the first part, I will try to just explain how the ChatGPT works and what is going inside ChatGPT, and with some core Python example. Based on your response and how you are liking, I will create the second part. So let's go. So this is a simple interface of our ChatGPT. So here, if we type something, then it's here we have searched for capital of India and it's giving us the answer. The capital of India is New Delhi. But how the things are getting processed here, we are going to see these things. So what is the thing happening? So the user will first give the input, right? Like that is the capital of India. And that input is going to the backend system. In this backend, there are multiple things we need to do that we are going to learn in the series. But for now, think this as a black box. In this backend, after few operations, they are going to send that question to this LLM. And then the LLM, this LLM can be anything. This can be ChatGPT, this can be Gemini, this can be Claude, or any other model. But the core concept is after taking the input or the question, this LLM is going to produce the answer and give the response to the user. So let's break down. When the user sends an input to a backend system, what are the core steps happening behind the scene? So the first step is tokenization. So what is tokenization? So computer don't understand words. For example, let's say if we send this word AI is powerful, the ChatGPT will not understand this. What is the question? So what are our tasks? So we need to convert these words to tokens. So what are tokens? So for now, think token as individual word. So here AI is a token, is a token, and powerful is a token. But let me clear you another thing. In reality, a word that doesn't mean a token. A token can be of anything. Let's say this powerful, this can be of two token also, like POW as one token, ERFUL as another token, or power as one token, or full as another token. So randomly it can be anything, but for now, for the sake of simplicity, let's take every individual word is a token. So see, first we are going to convert the words into tokens. So the format will be like this. It will be an array of individual words. AI is powerful. Then these words are going to get converted into numbers. So these are the numbers 101, 205, and 876. So this is a tokenization, converting the words into tokens and then the tokens into the numbers. This whole process is known as tokenization. See, for example, here, how are you? It can be either tokenized as like this, or it can be tokenized as 1, 2, 3 also. It could take one word. So based on different LLMs, the tokenization is different. In our series, we will see how to do the tokenization with some coding example and the real world example. But for now, let's take a sample or a mock-up of how the tokenization works. So this is a simple tokenization example. So here what we are doing, I have just created a simple function that is simple tokenizer, and that is returning the text into an array format. I am splitting the text in an array format. So here what we are doing, we are sending this text, AI is powerful. Then this text is going to this tokenizer method, and then it's going to send the tokens. So how it is going to do? Let me close these things. Python. So see here, this is the output. This is the text, AI is powerful, and when it gets converted to tokens, this is AI is powerful. But as I told you, tokens are numbers. But for the sake of simplicity, I am showing you the text. Again, this will be converted to numbers, and this we can achieve with the help of some library. Like for example, for ChatGPT or the GPT model, we use tick token for the tokenization. And how we can do that, we will see this all in the series. Next, when it gets converted into token, it will go for iterative generation. So what is this iterative generation? So let's get this example, but first let us see some visual. Here in the ChatGPT, let me ask one question. So I have asked a question and say it's generating answer. But if you notice, it's not generating the answer at once. It's generating chunk by chunk, right? See, it's generating chunk by chunk. So what is happening here? So first, the tokens are converted into vectors, or you can say embeddings. So what are these? Or embeddings are a way to represent complex data like words, image, or audio in a number, or that computer can understand. Or it will just, it's a map, basically embeddings map data into mathematical space. Okay, so for example, let's say we have few dimensions, right? As a simple analogy, think this of a map. What with similar meanings, for example, dog, puppy, are placed close together like neighboring cities, while unrelated words like say dog and airplanes are placed far apart. Okay, so think that of an embeddings. Then comes the transformer. The transformer is the engine. It's a deep stack of mathematical layers that process those vectors. Unlike older AI that read one word at a time from left to right, the transformer looks at the entire sentence at once. Okay, and this allows it to see the full context immediately. So basically, whatever the question we are sending to the LLM, it's going to see the whole question at a time. It's not word by word they are checking. Then at the third step, we have attention that decides important words. So what does this mean? Attention mechanism. So what is self-attention mechanism? So this is a paper published by Google. I will explain that in the series. But for now, think this, the self-attention mechanism calculates which word in your prompt are most relevant to each other. For example, let me give you an example. Let's say in a sentence, the bank was closed because the river overflowed. Then the model uses attention to link bank to river, right? The river, rather than bank to money. It weights the river vector because see, the bank, it can be the bank of a river also, right? And it can be a bank where we save our money. But which bank to consider? Based on this question, which was the river, the attention mechanism is going to decide what does this bank means. So this is the role of this attention, which decides based on the important words. Then in the fourth step, the model predicts what will be the next token. So model predicts next token means after all the mathematics are done, the model doesn't know the answer. It calculates probabilities. It looks at the pattern, it learning based during the training, based on everything written so far, what is the most likely the next piece of text. It produces a list of tokens, each with a percentage score. So think this of a guy as an analogy. You have a jigsaw puzzle, right? In the jigsaw puzzle, if you have something to attach, so you will go what is the similar image that is going to fit in that place, right? So LLM will decide which jigsaw puzzle, which piece is going to fit in that place. Then this loop gets repeated. That's why when the ChatGPT gives us response, it's not the whole response at a time. It's going through all these process and then it's generating the text one after another. Let's see an example. Here, say I have created one dummy next token function which is randomly choosing from this word. AI is very powerful. Okay. Now this is a generate token. This is the core function. So this is going to generate the tokens. But remember, each token is not generated at a time. It will be piece by piece, as we have seen, right? So what it's going to do? So it's going to first, it's taking the prompt, which is basically this AI, and it's going to split the prompts. Here the prompt is only AI. Then it's going for the steps. So what are the steps? So in generate token, basically here I have generated. Let's break the response in 5 steps. Okay, in 5 steps it will break the token. First, it's taking the next token. So from this whole array, it's taking randomly one word. Okay, like think this next token as all the 4 steps that is performing. That is, it's getting converted to embeddings. Okay, then it's choosing which word to choose. Then we are appending with these tokens, and then we are printing. Let's see. See, first it's the token AI, that is the main prompt, and then in the next token it's randomly choose AI and it's appending with the tokens, that is the AI. It's AI. Then what it's doing, then from here again, since it's a loop, it's again choosing the next token. So from this, so think this array as the collection of words that the LLM has been trained upon. So from this whole word, it's choosing which word to choose. Here we are choosing randomly, but in real world, every word will have a percentage or a probability. So based on the higher probability word, it will choose. So it's choosing powerful. Then with the same repetitive example, it's choosing is and the powerful again. So this is randomly, but in real world, it will choose which word will come based on the previous one. Then another concept come here is the memory. So what is memory? So memory is basically, it allows us to retain user specific details, preference and context across different conversations, reducing the need to repeat information. So what is this? So from here, let's say I have give me the difference between Python and Java, right? If I ask you which one to prefer for AI, so it's saying for AI you should strongly prefer Python over Java. But how the ChatGPT is or the any LLM is remembering the conversation? So basically it's taking the reference of this previous question and it's giving me the answer. So this is because of the help of memory. So any LLM where it's remembering the context, what is the previous conversation happened, and based on the context it's going to provide us the answer. Because here which one, this is ambiguity, right? Because otherwise it will not know which one. That means it will compare based on which to come or anything. But based on the previous chat history, it's going to see, okay, there is a question between Python and Java, so it is going to choose between them. So memory plays a very crucial role. In our next series or in the series, we are going to see how to create memory, how to retain memories, and how to optimize based on memory. Now, when this is already done and the question has gone to the ChatGPT or any LLM, what is ChatGPT really doing? So basically, ChatGPT is like a probability machine. As I told you previously, it will predict what is the most likely the next word. So for example, this is the input text that is coming. So based on this trained model or the trained word, it will choose which word is likely to come after this. And based on that, it's going to take. And basically, it will choose based on the higher probability. Let's take an example. Here, suppose the prediction. So what it's going to do? Suppose the ChatGPT created this answer. Let's say suppose I have asked a question, where does a cat like to sit? This is the first answer ChatGPT created. The cat sits on the, then after that it's going to choose the word which will be the appropriate word and which word has the higher probability to fit here. So let's say there are different words, mat, sofa, dog, refrigerator. Based on this word, see, mat has the higher percentage or the higher probability. So it's going to select the mat. So the cat sits on the mat. And then when this mat is selected, based on that, it is going to select the next word, which is the with the, see, it has the 90% probability. And then after that, it's going to select. So after this, which one is going to with the highest probability, toy or ball? So since toy has 70% probability, it's going with the toy. So now the answer will become the cat sits on the mat with the toy. So basically, This is the prediction mechanism, and also we can control this with the top P and top K that we will discuss later on. But in the prediction section, there are many things to discuss, but for now, let me give you a small code example. So this is the prediction example. Here, let's say we are calling this method generate sentence, and we are passing, and let's say that GPT has processed this answer. AI is. Now, what is AI is? After that, what it will come? So let's say we have this collection of words trained in the LLM: fun, powerful, useful, and amazing. And for now, I am choosing randomly from this array. So what's happening? So first, we are storing this prompt into the sentence. Then, as an example, I am looping 5 times. Then I am calling this method predict next word. So basically, randomly I am choosing the word or the token, and I am appending with the sentence. Let's see. See, AI is useful, amazing, fun, powerful, amazing. So this is a random text, right? But just for the example, see, it's going to predict the next word and going to append the thing. And also you have seen, right, the ChatGPT response is not at a time. It's going to check the word, it's going to append the word. So it's like streaming the response. In the real world project, in our series, we will create a streaming response. How to create a streaming response like a ChatGPT. So this is how a conversation memory work basically, but this I will teach you in the series. And apart from this, in the series, friends, we are going to see many important concepts like this. We are going to start with individual topic, like example, what are tokens, what is tokenization. With example, I am going to show you each and everything with a core Python example, so that you will understand what is happening under the hood. And then we will go to LangChain, and where you will feel why we should use LangChain and what are the restrictions in LangChain, and how to go beyond LangChain and can use our own approach, because LangChain will not provide everything. You need to go with some custom approach. So in the system design, that I will also discuss in our series, but as a whole, let me give you a simple system design. So at first, user will give the input, it will be tokenized with the help of tokenizer, then it will go to the model, and then it will generate an output. But in real production system, we are going with the client, that can be any application or CLI, that is going to our backend server. So in our final capstone project, we will use Fast API as our backend server. Then we will go with the prompt builder. So prompt builder is basically how we are going to build the prompt, the chat history, or basically with some different user role, we are going to give the prompt builder. There are different type of prompt, like one shot prompt, few shot prompt, n shot prompt, chain of thought prompt. So we will see everything in those series. Then it will be going to the conversation memory. As I told friend, memory is a very important thing. Based on this memory, the ChatGPT or any LLM will understand the previous context, and based on that, it will give us the response. Then it will go to the LLM API. Then it will be the response processor. So in the response processor also, we'll see there are many things happening in the response processor. We need to see the security concern also, so that LLM response can be guardrail, so it doesn't provide any unnecessary response, or how to guard the response so that it doesn't provide any useful information or some personal data. And then with the response processor, the final response, we are sending it to the user. But in this system also, we are going to include many other security concern, optimization concern, everything. So friend, these are all the things that we are going to see in those series. So basically in the series, we are going to see the token estimation, how to estimate token, because in real time you need to calculate the token, because every LLM is based on some token limitation. If you cross that limit, it will not work. Then how to do tokenization, how to do validation. So if the tokenization or the token number get increased, how to handle that. Then trimming the history. So suppose friend, if you send history message so long, it will be of no use. Then ChatGPT or any LLM will not understand. So it will forget what is the previous chat. So how to prevent that? We are going to see that. We are going to see exponential backup. So on failure, how to expect things and how to make LLM response on that, how to log errors, and how to loop continuously safely. And then we are also going to see cost tracking. So because at the end of the day, friend, your application should track the cost, and it should display to the user, because based on that you will send the bill to the user, right? So this is a very crucial topic, the cost tracking. Many courses will not teach you this cost tracking, but in our series we are going to see this exponentially. We are going to see this very minute and deeply. So friends, please support me. If I reach 50 followers or 50 subscribers, I am going to start this series. Thank you, friend. Hope you will learn many important concepts from this series. Not only concept, we are going to see the system design, interview, question answer, many more. I will attach the course syllabus in the description. Please have a look. And also let me know, friends, how do you like this and if any improvement I need to make. Thank you, friends. Happy learning.